So in this video, we'll use LINEST and matrix solution for power series decay regression. We'll generate a dataset from this equation where the value of A is 1 and the value of B is also 1. And the value of X will range from zero point 0.1 to 2. So let's generate this equation. Dataset is equal to A, array formula of A plus B over the X values. And we'll use power series to draw the trend line of this. So first we show the scatter chart of this data set, and we'll draw the trend line using we'll use the power series. So here we have the power series trend line, which is in the form of y equals 2.07. So y is now is 2.07. That's the value for C, times x to the power d, which is negative 0.648. We'll calculate these values using LINEST and a matrix solution. To do that, we'll transform our equation into the linear form. So y becomes ln y, and c times x to the power d becomes ln c plus d ln x, because the logarithm of x to the power d is d ln x. Then we factor out the x values, 1 comma ln x, which is this matrix, and ln c semicolon d, which is derived from the LINEST. So let's start with the value of the y values, the linearized form, which is array formula ln of the y values, and we fill up the 1 comma ln x matrix is array formula of the x values. Now that we have transformed our dataset into the linear form, we can calculate the Pijarina inverse, which is minverse and mult transpose of the 1 comma ln x matrix and itself. Then we can use the LINEST function, LINEST data y and data x, and we'll show the full statistics. We have 10 outputs. You'll notice the value of B1 of the LINEST is 0.648, negative 0.648, matches to our D in the LINEST, in the equation of the chart, negative 0.648. While B0 is actually ln C. To get the value of C, we use exponent of ln C, 2.074, which is 2.07 in the equation. So we can calculate these values using slope and intercept, starting with slope, data y, and data x, and then the intercept, data y, and data x. These values match to our LINEST output. Next, r squared can be calculated, data y, and data x. Stay x can be calculated also, stay x, data y, and data x. So these values match to our LINEST output. Then we calculate for the standard error of the coefficient, starting with B0. The standard error value of the B0, which is stay x, times square root of Pijarina 1. 0.024 matches to our LINEST output. And then B1, the standard error value B1 is stay x times square root of P Gerina 2. And it is 0.0265 matches to our LINEST output. Next, we calculate for the total sum of square, the TSS. Let's start with the n, the value of n, which is rows of the range. And it is 15. Now we can calculate total sum of squares, which is n times variance of population lny. Now we can calculate for the regression sum of square, which is equal to r square times TSS. 4.272 matches to our LINEST output. And we calculate for the residual sum of square, which is equal to degrees of freedom. But we have to calculate for the degrees of freedom, which is equal to rows minus columns. Rows minus columns of the range. And degrees of freedom of denominator is 13, matches to our LINEST output. And now we can calculate for the residual sum of square, which is DFD, degrees of freedom, denominator times stay x squared, which is 0.093111, matches to our LINEST output. Then we calculate for the F statistics, which is regression sum of squares divided by 1, because we only have one independent variable, divided by stay x squared. 596.558 matches to our LINEST output. This completes our LINEST and matrix solution for power series decay